A universe filled with galaxies, a cosmos crowded with planets, and yet only one known spark of life. But maybe we're asking the wrong question. We don't need to prove that life exists elsewhere. We only need to know if it's possible, and it is, because it happened here. Now consider the scale. Trillions of galaxies, countless stars, up to septillions of planets, thousands of times more than all the grains of sand on Earth. Yes, life may require very specific conditions. The right distance, a stable orbit, the right chemistry. But across such unimaginable numbers, is it reasonable to believe that it happened only once? If life in the universe is almost inevitable, then where is everyone? And to even begin answering that, we have to go deeper. Time to go down the rabbit hole. There's a thought experiment in mathematics. Given enough time and enough attempts, even the most unlikely outcome becomes inevitable. In theory, an infinite number of monkeys, typing for an infinite amount of time, would eventually produce the complete works of Shakespeare. It's called the infinite monkey theorem. And if something like that is true, if an infinite number of monkeys, typing for an infinite amount of time, can eventually produce Hamlet, then can billions of years and septillions of planets fail to produce life? Every living thing on Earth shares the same code, the same chemistry, the same molecular language, from the smallest bacteria to us, which suggests something remarkable. All life may come from a single origin, not necessarily because it was the only one, but perhaps because it was the one that survived. Life can take many forms. A single cell is already complex, but compared to us, it is almost nothing. Because between life and intelligence, there is a gap, a massive one, and crossing that gap may be far more difficult than life itself. The emergence of intelligent, organized civilizations may be far more unlikely than the emergence of life, because it wasn't enough for life to begin. It had to survive, adapt, evolve. It required a chain of events, each one increasingly improbable. A primate, leaving the trees, learning to use tools, passing knowledge across generations. Our own species came dangerously close to extinction, reduced to just a few thousand individuals. And long before that, an asteroid struck this planet, ending the age of dinosaurs and opening the door for mammals to rise. So many conditions, so many coincidences, that the path to intelligence begins to look almost impossible. And yet, it happened here, which raises another possibility. What if life is common, but intelligence is not? This is the heart of the Fermi Paradox. If intelligent life exists, why is there no sign of it? Because somewhere along this path, something may be stopping it. This idea has a name: the Great Filter, a concept proposed in the 1990s, suggesting that between simple matter and intelligent life, there are barriers, steps so unlikely that most worlds never make it past them. Maybe the filter lies at the very beginning, a biogenesis, matter becoming alive, or perhaps later, the rise of complex cells, eukaryotic life, orders of magnitude more intricate, or later still, the emergence of intelligence, a brain capable of reflection, language, organization, and technology. At any one of these steps, the process may simply stop forever, which would explain the silence. Not because life doesn't begin, but because it rarely makes it this far. But there is another way to look at this, not as a single barrier, but as a rare alignment, a hypothesis known as rare Earth. The idea that life, especially complex life, does not emerge easily, that it requires a precise combination of astrophysical and geological conditions. So unlikely that it may have happened only once, the right type of star, stable, long-lived, not too violent, a planet at just the right distance, where liquid water can exist, a large moon, stabilizing rotation, plate tectonics, regulating climate, a magnetic field, shielding radiation, each condition unlikely, but together almost impossible, which would mean that the silence of the universe is not surprising, it's expected, a universe full of planets, but almost no Earths. But there is another possibility, one far more unsettling. What if intelligent civilizations choose to remain silent? Because in a universe like this, being seen might be dangerous. In a battlefield, lighting a fire is not life, it's a signal, and signals attract attention, attention from others you know nothing about, their intentions, their capabilities, their limits. And if even one of them is hostile, then silence becomes survival. This idea is known as the dark forest hypothesis. The universe as a dark forest. Every civilization, a hunter, moving quietly, hiding its position, because making noise could be fatal. So maybe the silence we observe is not emptiness, but fear. But what if we are not one of those silent civilizations? What if we are loud because we didn't just listen, we spoke? In 1974, a message was sent into space, the Arecibo message, a signal broadcast from Earth toward the stars, carrying fragments of who we are, our mathematics, our biology, our DNA, and perhaps most revealing of all, our location, an invitation, or a mistake. Because not everyone agreed. Some argued that announcing our presence in a silent universe might not be wise. If the cosmos is a dark forest, then we may have just lit a fire, and once a signal is sent, it cannot be taken back. In 1961, astronomer Frank Drake proposed a simple idea. What if we could estimate how many civilizations exist, not by guessing, but by breaking the problem into parts? Stars, planets, life, intelligence, communication, survival. Each factor uncertain, each one a filter. Multiply them together and you don't get an answer. You get a perspective, a way to frame the question of whether we are alone or simply too early to know. The universe remains silent, at least to us. We keep waiting for a signal, something to break the silence, a sign, a presence, proof that we are not alone. But that signal may never come. Perhaps we wouldn't recognize it. Perhaps it's too far away, or perhaps it simply doesn't exist. In a universe this vast, silence may be the only answer we ever get.